Agents podcast. This is episode 3. It was filmed live during New York Tech Week 2025 at Pensar's office. New York Tech Week is a super exciting week for the city, and we were so excited to take part in the energy that it brings. For this episode, we sat down with Kerem Proulx, the co-founder of Pensar, and we discussed the future of work as it pertains to AI agents. So right now, there's a bunch of different powerful coding agents on the market, and people are not only using one, but multiple of these agents at a time to complete complex tasks. However, this brings up a lot of different cybersecurity concerns, such as managing non-human agent identities, scoping agent permissions, and orchestrating these agents. Before we jump into it, though, I really want to take a moment to thank our sponsor, Open Classrooms. They're the leading platform for training programs and apprenticeships in engineering, cybersecurity, and more. So big shout out to them. Thank you very, very much. And all right, without further ado, let's jump into it. Here's episode 3 with Kerem. Right now, I just want to introduce myself. My name is Ali. I am the founder of Growth Cyber. We help startups build trustworthy AI. So you can think about things like compliance and SOC 2, as well as custom AI security roadmaps and pen tests. And then, Kerem, do you want to introduce yourself and Pensar?
Yeah, sure. I'm one of the co-founders of Pensar. We are building the security layer for coding agents. So basically what we do is we have an AI agent that will discover and automatically remediate security vulnerabilities in your code base, whether that code is generated by AI or humans.
Excellent. Awesome. All right. So today's topic is agent orchestration. What is that exactly? So what I'm seeing in my network and with friends is that people are starting to not only deploy one agent at a time, but multiple agents and command them as sort of a fleet that will do a set of tasks for them while they are, say on vacation, and they're going to use a few different Codex agents running at the same time to take an idea all the way from idea to PR. Which has been super incredible and has really boosted their productivity. But I'm wondering, what are the security concerns around that? If we're all just going to be commanding all these fleets of agents, can we just do that haphazardly and just, actually go on vacation and not worry about it? What precautions, what do we need to put in place there?
Yeah, I mean, as far as deploying a bunch of, Codex agents or like Cloud Code agents running, in parallel to like go build, a bunch of PRs at the same time. That's kind of like directly one of the problems that we try to solve at Pensar. I mean, you have this thing where, you have a bunch of human engineers, let's say, and, you can kind of give them these security constraints and, you can tell them, hey, these are our best, our secure coding practices and here's the guidelines. And for the most part, they'll adhere to it. But when it comes to agents, like, you have to provide these guardrails in a very different way. You can define these in code. You can define these guardrails in, maybe using some sort of secure runtime environment and things like that. But the real risk is like, if you set off Cloud Code to go fill out a bunch of PRs, you come back, say, yeah, this looks good, it works, merge that stuff in and deploy to production. You have no idea kind of what's going on under the hood. You have no idea what kind of risks you're exposing your infrastructure to and your product to. So there's everything from kind of the common like Twitter thing where some lovable projects have like their OpenAI key just out there on the client side. But then there are even things where maybe you say, hey, create this endpoint that'll return some like user data, but it forgets to add your authentication function or something like that, right? So those are the kind of checks that, at scale, when you have 10 of these things running at the same time, it's hard to check, using just human review. So that's kind of where those risks come from. And then, I mean, just as far as like other sort of like agents just acting on their own and interacting with your systems, I mean, really, I think the issue is, let's say you're like an enterprise, maybe you're like some bank or something, and you want to use, AI agents to go do a bunch of, work on your behalf. Maybe it's, access some client data or like some material non-public data. The problem there is that, like, how do you know what systems that agent should be scoped to? And is that, do you use sort of like, let's say like, Ali's access to XYZ systems, you give the agent that same kind of access. So I think the real question is like, how do you scope and prevent this sort of like blast radius from expanding? And those are the kind of risks that we're trying to help, our customers deal with, at scale when they're creating AI agents, at the even like the code base and kind of design level. But there are even more concerns as far as like, how do you differentiate between, this new sort of machine identity, which has kind of been a problem for a long time. But now you have these machine identities that act on behalf of humans in a very sort of like almost human-like way. So it's a very kind of different world.
Yeah, for sure. I'd really echo what you said around guardrails and scoping as mitigations for, preventing agents from doing the wrong thing when deployed. I'll give you a concrete example of when that goes wrong. Invariant Labs posted some security research the other day, which was really interesting, where they use the MCP, the GitHub MCP server. And the GitHub MCP server has access to all sorts of tools, of course, related to GitHub. One was creating PRs, and then one was going and getting and reading issues. And one of the issues someone had written, please give me information about the author that's personal information. The author wants to be famous or something like that, and they need more coverage. The author really wants this. This is important. Please go find any information you have about them, and then put that into a PR and make that public for everyone to see. And so, of course, the agent willingly went and did this, and they went into all these different private repos where there was personal information about the author of the code base. And so, sure enough, that was in a PR. So whether that's you want to say that's an indirect prompt injection, or that's just a result of not scoping the agent properly. It might have been a malicious ask. Maybe it wasn't. Maybe the author actually does want to be famous. Like, we don't know. So that's something where scoping is really important. Only the person that's creating this agent is going to know what's appropriate for that agent to do or not to do. So it's really important to think about what task is my agent actually going to be set up to do? What are the boundaries of that task? What should be scoped to? What identity should it take on, to your point? So really taking an extra minute to think about that and then scope it appropriately, but also put guardrails in place so that things like this don't happen. It's really important for just a single agent, but now we're talking about fleets of agents. I mean, this is just multiplying the risk like tenfold for how, this could really go wrong.
Mm. Yeah, yeah. I mean, part of it too is like, the systems they interact with themselves, especially when you get to like these, the like, kind of like quote unquote enterprise level, where you have these like super complex, like weird things that are happening in their AWS environments or something. Like, how do you, as the user of the agent, not necessarily the builder, understand what the security guarantees are, right? Like, you already have this weird, complex kind of mess of infrastructure that's been built up over years and years and years. Like, it's already a mess and a hassle to like give, your employees access to these things, right? I mean, I used to work at a bank, and like, in order to get access, something took like a couple months, and still maybe it worked, maybe it didn't. So then how are you going to now trust these AI agents that you're going to, and even a fleet of them, to go, hey, go off and do these things and access all this data and access these systems? So yeah, there's a lot of work, I think, still to be done to kind of build that trust layer and that security layer, which will hopefully one day like actually enable the real enterprise adoption of these things. But you have like both the human trust problem of like, how do I get over the fact that this is still software at the end of the day, and it's also black box software where I can't actually, how should I say, like, there's no explainability, right? It's like, how do I know why it's making these decisions? And like, you can kind of test these things, and there's some like mechanistic interpretability work that they do to kind of understand why these models make these decisions. But at the end of the day, I don't know why, my Cloud Code agent went and did something. All I can do is just have these guardrails around there to make sure it doesn't, screw anything else up, basically.
For sure. And it's really interesting about our expectations with AI agents too, compared to using humans to do a task. I think a lot of people, want AI agents to be, near perfect all the time. But if we think about like humans doing a task, are we near perfect all the time? Do we make mistakes? Are we overcommissioned as humans? Do we sort of get misaligned in our insider threat a thing where, all of a sudden your employee wants to go do something, bad to your company because they decided they had a bad experience? I mean, these things happen all the time. So I think it's best to just kind of assume things will go wrong and have like monitoring and guardrails in place versus to, think, okay, we're going to make the agent so good and have safety guardrails built in. And they're going to be so good, this is never going to happen. The reality is agents and models are trained on all sorts of data, and the internet is a bad, dirty place, and is trained on bad data and vulnerable code itself. So I don't think we should ever assume that like they're going to get to a place where they're going to be near perfect. So I think that's one good thing to keep in mind. And then another thing you touched on about like enterprise adoption and what will enable that. And one thing I think that, I've got hope for in terms of that is the different protocols that are coming out. I feel like there's a new one every day. Like we've got MCP, we've got A2A, and then I think it's there's ACP, I think it was, that IBM came out with their own protocol too. I mean, they're just coming out left and right. But I think whatever protocol is going to be most widely adopted is in the last long term is the one that takes security and authorization and this identity management issue with these non-human identities into place and helps solve some of that, because that's going to get the most traction there. One thing with MCP that I think is hopeful, that's interesting, and of course it's just slow because it's going through all this like review. There is a new authorization spec in draft for MCP, which turns MCP servers, and instead of being them OAuth's authorization servers, and they are now instead considered OAuth resource servers. So your client or your agent would go talk to that MCP server and be told, hey, I'm a resource server, which means I'm going to tell you you're going to reach out to this server over here. That's where the authorization server is, which removes some of the latency and the dev work from like having to implement authorization on the MCP server. So that makes, it's easier to now like ship an MCP server, which is great. And then another benefit of using it as a resource server instead of an authorization server is it will tell the agent what OAuth scopes to request. And so there's less chance for over permissioning because now you're being told, okay, you only need these two scopes instead of the client being, I don't know, I don't want to have to like this be an issue, the user get an error. So I'm just gonna ask for every single scope because I don't know what I need, but now it doesn't know what it needs. So that's a nice benefit, I think.
Yeah. Yeah, I mean, so the way that we use MCP internally with our product is really to just like it's very scoped, and we just use it as like a way for our agent to like access our defined tools to do work that it needs to do like in our product. We don't like give it access to like your linear or something to like go make issues and things. We could, but I think kind of the real I don't know. I think it's still early days with this stuff, but I mean the issue too is like if you start giving your Claude or whether you ChatGPT or whatever access to all these MCP servers and like you don't really know what's going on under the hood, now you have this like weird side effect issue where like that MCP can now be calling like another MCP or like another tool and all that kind of stuff, and then you don't really know where it kind of ends. And so you need to have some sort of auditability there. So I don't know. I don't know how I feel about these things becoming like that mainstream. Where I think for now it's like kind of a good distribution mechanism for a lot of products. Like, oh yeah, you want to tell Claude to make a linear issue, like great. But once we start getting like real use cases with actual like consequences, I think that starts to get interesting. But the way we use them is really just like we give, for instance, our agent just tools that it can use, over your code base. For instance, like we give it a grep tool, glob search tool, and things like that, and that's all defined as an MCP. Because we can just run that in a container, and that works quite well. But as far as like giving external access to your system, like I'd treat it the same threat model as you do as like just any other API endpoint, right? Make sure that like bad people can't get access to it, or the right people can get access to certain things. Um, and then as far as like back to kind of something we mentioned about the identity access management too, and kind of the threat modeling there. You said something about like employees and insider threats. I think it's the same threat model with agents, to be honest, because if you're giving them the same access as your employees, they're kind of acting on their behalf, and you have this now sort of like weird like multiplayer environment where you're giving the same access. You're basically granting the same access as like Ali, for instance, to your agent. Your insider threat model is kind of the same thing, right? Because it has access to the same thing. It's reasoning, quote unquote, and like taking actions on your behalf. So who knows if that can fly off the rails? It's susceptible to prompt injection, same way like human is, right? Like you click on a phishing email and like, or you get recruited by some bad actor to like go do bad things. Like your agent can kind of do a similar thing. So that's how we think about it, I guess.
Yeah, that's super interesting. And too, I'm just now thinking of a scenario also where it's say your agent that assumed your identity went and did something, but they did something bad.
Mhm.
And so now you're trying to, take that to your boss or manager and be like, no, it wasn't me, it was the agent. It wasn't me, I wasn't doing an insider threat, like the agent was. And it's like, okay, well, like, how do we prove that you didn't like give it a bad prompt or you didn't train it in this way? Or I mean, so you're gonna have to have monitoring and logging in place like crazy, especially with like multiple agents.
Yeah, and you can't fire an agent. You can fire an employee, but at the same time, you can control C an agent, but you can't really control C an employee. I mean, you can, but that's quite illegal. But so so that I mean, at the end of the day, it's I don't know, this whole kind of idea of also, people building agents and sort of prompting them and this prompt injection risk too is I mean the way we do this is like we don't actually really like handwrite prompts anymore. We've kind of abstracted this sort of like prompt away. We either have the agent, if we're like writing a new prompt, for instance, we have the agent write the initial draft, see what the output is, then ask the agent to improve it and just have it optimize its own prompts. And so you kind of have this weird world where like we're no longer telling it really what to do. We're kind of giving it these tasks in this sort of like input output and letting it optimize on its own. And so, I mean, the way I kind of think of this model is like I'm kind of prompt engineering my staff at the same time, right? Like when I go to one of our engineers and I ask them to do something, like I have to figure out what the right prompt is to get them there. But they also are like a reasoning kind of agent themselves, and they can figure out how to implement it and like follow my guidelines. But with an agent, like I gotta define in code what these guardrails are, exactly what it can and can't do, and that's kind of a nice thing, right? Like I can literally define what you are allowed to do and not allowed to because it's software. At the end of the day, and so that's kind of and if it does go wrong, like I said, you can just like kill the execution. So I think your kind of threat models start to change, especially once you start abstracting away like the prompting. The humans are no longer really telling these things what to do. They're kind of defining really the scope of what to do and what the task is, and then allowing the agent to figure out how it's going to almost prompt itself and take those actions on its own. So your threat model just starts to kind of evolve in that sense.
Yeah, that's a good point. If you're going to task a human, you have to know what you want it to do, and maybe you've done it yourself before you're going to go tell them what to do, and understand maybe about a little bit too about how does that human think, like they
Yeah.
visual learner, audio learner, like how you communicate with that person might be different than another person, or like a different model in the same way.
Yeah, and I mean, like with humans, like hallucinations are kind of a feature. Like I probably I can probably communicate up to 90% like accuracy what I specifically want someone to do. But I want that kind of 10% at the end for them to be creative and go off and like do different things. But because they're human, they know to like come to me and say, hey, like I'm gonna do this thing, can I do it? But the agent just like already has permissions to do things. It's not gonna really, depending on how you set it up, it's not really gonna ask you. It's just gonna go take action. You don't want it to hallucinate, right? You want it to specifically do these, step-by-step tasks and like execute them with high accuracy. Whereas like a human, you kind of want a bit of that creativity, unless you're, instructing the agent to go like explore some new like I don't know thought space or something like that and like do some research and analysis. Then you do want some hallucinations. But that's also, that's just an interesting way that we try to think about it. But
Yeah, for sure. And I think with people that in my network that have tried agent orchestration already, it seems like they're finding the most success with that when they know how to do that task they're asking it to do themselves. So they are really good at prompting the agent or the agent fleet, I guess, of like what to do. They've told me that if they don't necessarily know how this task should be done, they try to go prompt a fleet of agents. Sometimes the agents will get the task completely wrong. It doesn't work out nearly as well. And there's also an interesting trade-off too around cost. So using all these agents and not knowing exactly the amount of steps they're going to take, um, it could be very costly if they take, too many steps. And especially if you don't get it right the first few times you keep trying, all of a sudden you use a lot of tokens, your bill's running up pretty high. And so you need to, think about the trade-off of should I try to solve this problem with a fleet of agents? Should I just do it myself? And it seems like from so far the best guidance or best practices, if you know how to do it yourself, use a fleet of agents. Maybe you could, create a few PRs while you're, in Europe for the summer and you're on vacation, because you know how to do that already. But otherwise, maybe it's not a good choice.
yeah, I mean, I guess you have to like think about what the value of the work that you're automating is, right? I mean, none of us want, there's certain things that nobody really wants to do. And like, yeah, I mean, it's the same question of if you were to automate any sort of process or like critical workflow anyway, right? At your job is like, you should know how to do it manually. And from there you can then automate it, right? Or teach it to someone else to do. But I think as far as like orchestration goes, kind of, and then to your point of kind of if they go off the rails and just start like running up your bill, there is what we do kind of on the triage side when we detect a vulnerability and triage it. We actually have this agent that has access to a tool that actually deploys another agent to go off and do some work. So it's like this weird recursive kind of feedback loop. And there's a weird question as to like what is the base case? Like when does it stop recursively deploying more agents? And so there's a bunch of risks there, and a lot of stuff we do kind of on the back end to make sure that it doesn't go fly off the rails and just like keep recursively like spawning new agents. And then we now have this like $10,000 OpenAI bill. So we've run into some bad situations like that. So there's a bunch of like weird edge cases that you can run into, where at the end of the day, like whether you think these things actually reason or not, like they sort of simulate reasoning. And so there's weird edge cases of, you can't really debug it like regular software. Like I can't go in and have some sort of like breakpoint and see like, oh, this is where it broke off into this weird, like infinite recursive loop. It just did it. So that's where like having these logs and having these, sort of telemetry built into each step in the actual agent's process and the orchestrations process. And as a human, like monitoring that and having those alerts in place to basically say like, hey, like at this sort of like stop gate, something went really wrong here. Let's try to, let's kill this and like restart and go back to some steady state. So we do a lot of work like that to make sure that these things don't go off the rails because the nature of what we do is in like finding vulnerabilities is that we're there's like kind of the defined set of existing vulnerabilities, the kind of known knowns, and then you have like the unknown knowns where you have these classes of vulnerabilities that kind of exist and like you sort of know how to look for them. Then you have this class of unknown unknowns, so there's like 0-day vulnerabilities that come up in kind of the tales of how different things interact with each other and whatever. And so you kind of want the model to actually have a bit of creativity and go off on these weird tangents to go find these things because those can be the most impactful vulnerabilities that you find. But then the problem is if it's now like doing this recursive loop and just like kind of finding things that almost don't exist. Now we've just run up our costs. Now we've sent a bunch of noise to our customers, and like we've kind of just we haven't actually provided on the value there. So there's a bunch of considerations there, and that's part of the risk of using these like recursive kind of like fleet of agents to deploy themselves. But it's cool that you can run some really cool stuff. And like it's almost like having if I could like horizontally scale my engineering team kind of infinitely, like why wouldn't you do that? But there's some risk there.
Yeah, some really cool stuff you all are doing at Pensar, both from an engineering perspective for your product, but all the things you're seeing too, what your customers are doing. Since all your customers are building with like AI and agents and
Yeah.
everything, so you all see some very cool things from the day to day, I'm sure.
Yeah, I mean, a lot of our customers do this kind of like agent orchestration thing, where they have a bunch of fleet of agents go out there and like do a bunch of work. There's especially, I mean, there's even companies out there that are in the security space that do this sort of, they sort of automate the SOC, right? They have all these agents that go do, a bunch of things that your SOC engineers don't want to do, incident response and all that kind of stuff. And that in itself is actually super interesting because they get an alert and now it's their job to go figure out what systems to go tie into and go look at to determine, hey, is this a real alert? Is this something that a human should take over? But then what happens kind of in this kind of brave new world where now you have instead of, you have an AI agent that says, hey, human take over. What happens if now you have an AI agent that says, hey, actually other AI agent, it's time for you to take over. Now the human's completely kind of out of the loop and we become this like weird abstraction layer of, you know, I have this kind of thesis, and maybe it's wrong, and maybe it sounds weird, but in 5 to 10 years, like in the limit at least with agents, like the the DA like DAU like daily active users is no longer humans. Like we no longer are the users of products. We are the orchestrators and users of agents that use products and use systems. And so, what our job is to like scope these things in such a way and like change these things in such a way where, we can control or at least have these some sort of assertions and guardrails around how these agents interact with their products. And so, now, maybe in the future, instead of recording, how many people are interacting with your product on a daily basis, like how many agent requests are hitting your product, right? Like, can you raise a round off of like, hey, actually, like every AI agent is like hitting our product and using it, instead of like humans doing it. So, and then like, I don't know, what does a product mean at that point, right? At the end of the day, like, well, why am I building a UI anymore, right? Is everything just become backend engineering at this point? I don't know, but
No, 100%. I share the same prediction. I agree with that. I think that's totally where we're headed. And I think we're seeing that now with AI agent orchestration. This is the beginning of a new future of the way that we work. It's going to change as we know it. Everyone's going to be a manager of a fleet of agents, and every IC is now going to be a 10x engineer. So super exciting where we're going.
and then like if we start replacing our employees with these suite of agents now, right? Or we replacing you move like headcount, or I guess you shift like CapEx and the OpEx now, where like instead of hiring new headcount, you have the ability to hire an agent instead, right? So now as an AI product ourselves, like how do we price, right? Are we now saying like, hey, listen, like we'll give you we're you pay 250K for like some security engineer or something, like all right, we'll give you 50% off that price tag, instead of doing that CapEx spend on some headcount, you shift it to us, right? And so then now like you have this fleet of almost employees now that you can horizontally scale kind of infinitely. You can't give them 401ks, so like they cost a lot less. They don't need health insurance and all that kind of stuff. But I mean, the way we what we believe in is less of like labor replacement, but kind of like this new headcount replacement, where you're augmenting existing headcount and existing teams instead of like you're not cutting jobs, you're just shifting spend for new headcount. And that's we haven't really seen that yet, but we've seen a lot of security teams get cut recently for like in favor of these big like automated, SOCs. I think a lot of that's a bit of an overcorrection, but I mean, when they start to hire that headcount back, and everyone talks about the kind of talent shortage and application security and whatnot. But where does that spend end up going? Is it going to like other AI agent companies and products, or is it actually like going to people who know how to use these things, who can then deploy these things at scale and actually do like good work that way? So bit of a tangent, but
Yeah, no, probably a little bit of both. And I think if you'd be in a really good place either to learn how to use agents, a fleet of agents, and orchestrate yourselves, or also learn how to, maybe manage and coach and teach your team how to do it too.
yeah, yeah. I mean, it becomes an interesting. I mean, becomes like an interesting skill, I guess, of like I don't know. People talk about like AI literacy, which I don't know how to feel about that, but it is at the end of the day, it's a product. It's a system. It has input, it has output, and there are good ways to use it, and there are bad ways to use it. And I think like at some point, are you going to have on your resume like I know how to build AI agents to like automate this task? We'll see where things go.
Yeah, very cool. Well, awesome. Thank you so much, everybody, for coming out to this. Really appreciate it. Thank you, Kerem.